Okay, well, hello, I'm Graham Allan. I'm here from the Minnesota Supercomputing Institute at the University of Minnesota. And I'd like to share a bit of our use of OpenStack over the last 7, 8 years, how we put it in the hands of our users, and how our directions changed over that time. It will not be a very technical talk. Oh, and the screen just flipped. Cool. Okay. So first, a little bit about MSI. This is where we work at the U of M. It's kind of a spectacular 100-year-old building with our offices upstairs, and to everyone's surprise, 1-point-something megawatt data center in the basement. So that's where we have our HPC clusters, storage, and other infrastructure, including, of course, OpenStack. And we provide resources to every campus, college, and school in the university system. We're one of several service providers. There's also a separate central IT organization and a few other more kind of domain-specific providers. And right now we have probably close to 1,000 research groups from about 120 departments around the U, and maybe another 20 or so departments from other universities outside the U of M. And traditionally, we've been very focused on, I guess you would say, traditional batch scheduled HPC, but that has really been broadening vastly over the last 5, 6, 7 years. And well, speaking to that, one of our major roles is really to help researchers find the right resources to solve their computing problems. And if we don't have the resources ourselves, direct them or connect them with someone who does. So that might be DOE facilities or NSF or indeed Jetstream 2. Going along with that, if we don't manage to connect them to a suitable resource, they will find their own solution. And that doesn't necessarily always come out with the best long-term results. So we're very motivated to find solutions for our researchers. And that gives a little context for why we originally built Stratus, which was our first user-facing OpenStack system. We had experimented a little with OpenStack at MSI, maybe as early as 2011 with Cactus or even Bear. That was actually before my time. But when I joined MSI, we started working on building Stratus. And one of the primary drivers was to support researchers working with restricted data sets, not necessarily HIPAA or data sets with specific like FISMA compliance levels. It was more for NIH genomic data sets. But the main HPC clusters at the time didn't really have the compliance controls you needed. But we also had some other use cases we'd like to address, like persistent services controlled by the researchers that wouldn't fit particularly well into a batch scheduled system, and more general self-service computing. And so among our goals, we knew we could build this out at a lower cost than commercial cloud. For the most part, all of MSI services are often at no cost to our researchers. But for this, we decided to build it out as a cost recovery subscription service, partly to discourage superficial users and support burden. And we also, we wanted to avoid data movement and try and retain perhaps a little better institutional control over that data. And certainly one of the non-goals was ability to scale to thousands of VMs. It was relatively modestly sized. Most of the target workloads we could see tended to be like single node at best. And so, well, the resulting design really came out as a fairly standard OpenStack environment, using a very standard set of common core OpenStack services. Most of the extra work involved was in building out encryption for data at rest, mangling the Puppet code to wrap all the API services in SSL, which wasn't supported out of the box back then, and folding in like single sign-on and two-factor authentication. So with that, I mean, the cluster is now built, and with the easy part done, I'll hand over to Edward to describe how it fared in the real world.
Thank you, Graham. Yep. Now that you know what we built, let's talk about onboarding our first users. Oops, that one. Okay. Cool. So this was completely new territory for us. So we wanted to kind of do a slow rollout. Our first users were actually staff who were Linux power users, and their first use was to benchmark the system because we wanted to see what kind of performance we would expect. After we onboarded them, we got a lot of questions such as, how do I schedule my jobs? Because they were used to running on the main clusters. How do I run some specific software package? And also, where are my files? Because they had completely different home directories from our common system. After the benchmarking was finished, it was time to onboard our first researchers. For our first onboarding, we had 4 researchers, and the researcher I was working with was very excited at the beginning. She was going to have root access on her instance. It was going to be life-changing. Everything was going to be much better. So we get to talking, and we start breaking down the responsibilities. I mentioned how she's going to be responsible for updating the operating system, and here's how you do that. And anyway, by the end of the onboarding, she actually was threatening to retire if we made her use the system. So that was a very memorable experience. Okay. Another thing we noticed is we onboarded a few groups, and then we quickly found that some of our groups that had larger data sets wanted to use Stratus. And these were users who were used to using large HPC nodes, some of which up to 1 terabyte of memory. So with our hypervisors, we can only support 56 cores with up to 256 gigs of memory. So they quickly found that they needed more than 1 instance in order for their data processing needs. This led to some issues because we started getting questions like, how do I share files efficiently between these VMs? How do I manage users? Stuff like that. So we set up a ticketing system for kind of basic triage, and we were expecting questions like, I have trouble logging in, I need more resources, stuff like that. But then we started receiving those other questions about how to basically be systems administrators. So we quickly found out that we weren't quite staffed for this, but researchers were willing to pay for the convenience of not having to do it. I know Graham actually wrote some Ansible scripts for one group to manage file mounting and user management. And then the Minnesota Supercomputing Institute has a group called Research Informatics, and these are scientists that you can contract with to process data. And we found that about 60% of our users were willing to pay RIS to do the processing for them. About 20% had the internal expertise to manage the Linux systems and do the processing themselves. And then the final 20%, we have no idea what happened. We gave them the project, we onboarded them, and never heard from them again. Some of which are actually still paying for projects. So go figure. Now for the operations experience. At the time, well, we were and continue to be a Puppet shop. So at the time, we figured we're Puppet. Let's use the OpenStack Puppet project for managing our OpenStack cluster. It worked in the beginning, but we found that over time, it became hard to manage. It just took a lot more time. And we also found that between our development cluster and our production cluster, there were large chunks of code that just were completely different. So it was really hard to test changes in development and then roll them over to production with conviction that you were going to get what you wanted and you weren't going to have a big outage or something. I remember so my first OpenStack upgrade, one of the primary people in the project was leaving, and I was going to fill in for him after he left. We were behind the latest version by about 4 versions, and he wanted to leave us on a good standing. So he wanted to do all 4 version jumps in 1 week. And I'm betting you can all guess how that went. We got through 2 that week, and it ended with the week ended with 36 hours straight of kind of slight panic as to why the cluster wasn't working. And we did eventually figure it out. It was about 4 p.m. on a Friday, so I was really happy that it was Friday and I could go home and not think about this anymore. But it was quite the experience. It was interesting. I learned a lot of good things. Perhaps one of the most interesting, though, is that Papa John's will in fact deliver pizza to my office at 11 p.m. And I, yes, and I hope never to use that information ever again. Oh, and the final thing I want to mention is the time. So we started off with about 3 part-time people working on this project for kind of the development. And then after it rolled out into production, time resources were continuously cut to the point where it's now actually just me keeping our OpenStack cluster running. So yeah, that's been fun. And now I'll turn it back over to Graham for the retrospective.
Thanks. So yeah, I was going to talk a little bit about what changed over time, touch on what worked well, what worked less well, and obviously what we do differently next time. So number one, I think, as you could hear, the environment never provided the kind of magic one-button solution that our users obviously hoped for. And, a lot of that was handled through them simply contracting to our risk group to do the analysis for them. That went on for some time. Also, over time, the mainstream HPC clusters kind of caught up in many ways. The compliance controls got into place, and a lot of the users were able to migrate back to what was for them an easier managed environment. I think anyone in this world has found that making your users act as sysadmins isn't necessarily a great model. A few of them will thrive, but many of them are going to struggle. And then for more of the self-service use cases, again, I think in most cases, the main HPC clusters caught up in a lot of ways. A lot of that was through being able to people run their own software in containers using Singularity, and also just more elegant interactive portals like Open On Demand instead of like vanilla Jupyter Hub. Doesn't match the flexibility you can get out of a infrastructure as a service, but it provided enough for the majority of our users that they did not need to go to that extra level of effort. But something we did find, we were creating more and more kind of generic hosting tendencies for internal, special, large projects. And so I wanted to talk a little bit about that. Besides our main kind of what you would think of as standard operations teams, MSI also has some DevOps and informatics teams who work closely with various researchers on specific collaborative projects. So agroinformatics is one big example for us. And then another one, I think we probably have between 10 and 15 FTEs in MSI working on neuroscience projects. And really, this is it's evolved to where this is now the majority of OpenStack use cases. So in review, for us, the Stratus project did kind of kickstart a lot of cultural changes for us to support secure and compliant systems in a more kind of DevOpsy approach. And this kind of aligned with similar activities going on in other environments at MSI. So in many ways, those other environments caught up. Another aspect is, as Edward alluded to, operationally, we cut back our effort a fair bit after production. I think we probably had 2.5 or so FTEs working on it through development, and now probably 0.25 at this point. And so there were a lot of things we would have liked to have gone further. Like for one, we found ourselves kind of stranded on the OpenStack Puppet to deploy when we could see the rest of the world had moved on as early as 2018 probably. And when it came to like some of these other use cases, like the user who had multiple VMs, needed shared storage, having some extra kind of OpenStack services behind that, like maybe some vanilla or heat at the minimum, would have been nice. And we kind of kicked the tires on that, but we never really got it deployed. And perhaps that was for the best, because there weren't really that many users in that category. But on the whole, we didn't really appreciate how much time it would take to keep up with OpenStack development, and that's a key thing to treat differently going forward. I've always felt since then that OpenStack's very much like a shark. If it stops moving, it's dead. So, but with that, back to Edward to talk about what the future holds.
Thanks, Graham. I see we're running a little short on time, so I'll try to be a little fast. Oh, okay. More time than I thought. Great. So new beginnings. So we found that our users don't really want root or don't really want the implications of having root. So going forward, we're going to focus more on our collaborative projects with our DevOps teams and be more of a hosting platform. Our time, we won't have any more staff time going forward. We'll have a little more staff time going forward, but there'll be more than just me on our next OpenStack cluster, which I'm looking forward to. But we won't have enough to really keep going on our own. So we will be partnering with Stack HPC to help us stand up and maintain our new cluster. And we had a pretty good size. It worked well for us. We had about 1,500 cores, and we're going to stay in that same area for our next cluster as well. And we'll also be adding GPUs, which will be fun. Goals. So Sky is actually the name of our next cluster. One of the things we're excited about is better support for containers. We have some exciting use cases for Kubernetes that we're looking forward to kicking the tires on. The dynamic environments from Azimuth, since our users aren't big fans of having, the implications of having root and the system maintenance, the push button apps for like Jupyter Notebooks, and Binder Hub will be great for things like labs and classes that we teach. So that'll be great. And the GPUs, will use those for running large language models, which is not something we had before in OpenStack. What we would repeat. The security first posture worked really well for us, but the security concerns are going to be different. Before, it was processing genomics data, but this time around it'll be FISMA that we'll be thinking about. Starting with the dev cluster worked really well in the beginning. It was just our inability to keep it up that was the problem. So we're going to definitely start there again. In Ceph, we have a lot of in-house experience with Ceph. We have 3 production clusters at the moment, and it's worked well for us. So we'll continue to use Ceph going forward. So, yep. As I mentioned, the test cluster will be very important to us. So we will start there first and continue to maintain it going forward. We'll use more modern OpenStack deployment tools. We tried Puppet, it didn't work well for us. So this time around, we're going to use KOB and Cola Ansible, and hopefully not have another one of those 36-hour upgrade nightmares that I hope never to repeat again. The Azimuth, the push button user experience for labs, that'll be great. And the rich metrics. We don't have any sort of metrics on our OpenStack right now, so we don't have insight into the utilization. We know the core count of what's in use, but we don't know how efficiently those cores are being used. So getting a better insight into that so we can plan upgrades and future needs will be very helpful. And finally, in conclusion, we found that research computing is constantly evolving and changing, so infrastructure as a service needs to adapt with it. The easier you can make doing the right things, the better. So we aren't planning to have researchers directly interact with OpenStack for this iteration. Instead, we'll have our developers work with it for hosting finished applications that can be consumed directly by our researchers. And with that, thank you for your time. And are there any questions?
We have time for one question. Anybody have a very pressing item they want to ask of these gentlemen? All right, they'll be available during break for questions. Oh, we do have a quick one. Jason.
Reverse. One hop this time.
I didn't hear the question.
Yeah, so I guess one thing I wanted to ask was as you find as you're, say, adopting these more modern high performance computing systems, have you found that you've had a lot of demand for like Kubernetes oriented workflows, or are you still finding that people still kind of want that traditional like batch scheduling environment with Slurm?
I think most of the pent-up demand for Kubernetes is coming from like internal development projects. Like, there's a lot of projects that are using containers a lot more. And thus far, a lot of them have been using maybe more simple orchestration methods. Like, I did some stuff with Docker Swarm because, it was easy to develop. You could basically a one-liner to set it up, and you can just move on and learn how to glue things together. But Kubernetes is clearly like a much more scalable and modern environment for that. And I think we've got a lot of projects that would like to use that, probably including elements of these are use cases outside of the main HPC that like targeted to these specific projects. So perhaps, custom Jupyter Hub notebooks, dynamic Slurm environments to run jobs. We see a lot of use for that.
Thanks.
Great. So our speakers will be available during break and lunch. I hope you reach out to them if you have additional questions. Thanks, guys.